which, to put that in perspective, is larger than the Windows NT kernel and the Linux kernel and stuff like that. And most of the code was written back in the 1990s when nobody cared about security. So anyway, it has a bewildering array of features. There's an OpenGL rendering engine in it, so you can render 3D objects onto your PDF document and animate them. It has a ODBC database connector, and there's a funny line in the documentation on this that it's basically up to it's a responsibility of the database administrator to ensure that their database is secure, because anything that's visible from that user account or whatever you can connect any database you want from it. Anyway, so you can embed Flash files and QuickTimes and MPEG streams and audio streams and all kinds of media formats. It has form input, and it'll also do digital signatures on the form input before it sends it off to some machine, some server on the network. It does XML RPC. There's a full JavaScript engine in it, which has full read and write access to every piece of metadata in the document. You can write files to disk from JavaScript, although in the newer versions they restricted a lot of that. So now you have to manually turn most of that on, and so it's not on by default. There's also, you can also store persistent variables between sessions of a particular document. So the first time you load the document, you can set a variable, and the second time you load the document, you can read the variable and take some action. It's currently restricted to the same origin, though, for the current versions. There's Adobe has a document search engine that you can interface from PDF. Has a quote digital rights management support, which is it basically sort of encrypts a bunch of objects in the document, and then there's like a bitmap field for whether or not you're allowed to print this thing or save it or edit it or modify it or whatever. And it's basically up to the client to actually enforce that, because you can just read the objects out of the file if you write your own reader. You can attach arbitrary files, and interestingly enough, apparently if you attach a PDF inside another PDF, you can then load that PDF from the outer PDF when you open that one. So you can nest PDF files within one another. You can also have alternative text streams for different locales, and also for doing like text-to-speech and stuff like that. So, also you can have a page rendered differently depending on whether it's going to a screen device or a printer device. Also, every single object in the document you can have an infinite number of revisions on. Well, almost infinite, but it's 65,000 versions of any particular object just by simply appending a new copy to the end file. And when I was reading through the spec for the PDF, I was just amazed when I came across this. So I read this and I was like, no, they couldn't have possibly done this. There's a launch action that basically launches that will run an arbitrary executable file when you say open a document, and I was like, no, they couldn't have done it. So, I was thinking, if you set the file to like command.exe, it would run it, but no, it actually does. So this became big news a couple of months ago because Vier publicized it. But there's like a bunch of stuff like this too. All of the media types, you can also set an arbitrary executable for launching the media type also. And I don't know if that currently how Acrobat's handling that either. It's sort of on my to-do list. But anyway, so currently the big official standards document on PDF is ISO 32000-1, and it's somewhat telling that there's in the very beginning of the standard, it says that there's nothing in the standard for actually, validating that a document or that a PDF is actually well formed. And so remember this, because this entire talk is sort of hinges on the fact that basically no two PDF readers read a PDF in the same way. So the original design rationale for PDF was that, well, I don't know if you all remember PostScript, but PostScript is basically Forth with graphics operators, and it was fully Turing complete, so you could write a ray tracer or a chess playing program that would run on your printer. But it also for just generating the pages. If you wanted to jump to page 100, you'd have to essentially execute the code for generating all the pages 1 through 99 first, which is a real pain in the ass. So a PDF essentially is just a big tree of objects you can just quickly jump to. For when you need to go to page 100, you just go to that object. So typically, a PDF generally looks like this on the inside. There's pretty much each object has a number, and generally it'll have a dictionary or something in it with it's just an associative array. So there's like a page, and it has a parent object and stuff for which object points back down to it. It's sort of a doubly linked tree or a directed graph. So, anyway, so you separate properties, like you say this page is 8.5 by 11. You can have an object that's like an action that runs JavaScript like this, pop up a message box. And so generally, there's a couple of primitive types. Has booleans, integers, strings, and hex strings. It's all very straightforward. It has arbitrary names. You can essentially rename any data type to something else. Arrays are basically written like this, and just lists, and then dictionaries are associative, where it's key value, and so forth. A string is basically like just a ginormous string, but if you wanted to put instead of having like a 23 megabyte long string, you just put it in a string or whatever. There's a special null object, and anything that doesn't exist is also a null automatically. So, and then basically an object definition is this is the object number. That's the version. Use the object, and then whatever, something from whatever, and then an object. And basically, whenever you use a reference to that number, essentially whatever's in here gets substituted in that spot. So, for example, if you define object 2 to be a string that says hello world, and and object 3 is, whoops, sorry, is referring to it, then it's essentially equivalent to a single object that just says example hello world. See? Although this doesn't quite, it doesn't work at the parse time though. It seems to work at evaluation time. Otherwise, something like this would work, but this doesn't work. And if something like this did work, actually it would make the PDF language itself Turing complete, because you essentially have lambda connectors at this point. Yeah, so basically this doesn't work because these aren't actually evaluated until, these aren't actually dereferenced until they're used, and so this is never actually really used when it's looking for certain types, because it's looking for names. This does work, so anyway, like I said. So you can read a stream from a file on the disk. In newer versions of Acrobat, this is restricted and you have to turn it on. It's in this menu here, and there's a ton of other stuff you can do on the streams. Every stream can be encoded in one of a dozen different encoding schemes. applications, and possibly all of them simultaneously. You can, there's in the later versions of the spec, there's a stream object, an object stream, where essentially you take several objects and put them inside of another object, and then compress that, and base 16 encoded, anyway. So just want to look at that. There's one of the things that Dia pointed out a couple of years ago, and it's used a lot in Metasploit, was you can do hex substitution on all of the name strings. For example, it's by doing that pound sign and the hex value. The strings all accept C-style / codes, and you can put an arbitrary amount of white space anywhere you want for most of them. So Metasploit does most of these automatically right now when it generates PDFs. So the actual, if you want, for the actual graphics rendering engine, when you actually draw stuff on the page, it's a completely different language. Once again, it's similar to a lot of the old PostScript graphics operators. So if you're with writing stuff in PostScript, it should mostly be the same. But generally, the tags are essentially done to either parenthetically wise or essentially do sort of the fourth style of arguments and then an operator for unary operators or whatever. I don't know. Or no, actually, no, it's more than that. But I haven't actually dug really deeply into these yet. Anyway, but generally, these are sort of the big classifications of operators. So you sort of nest. These are kind of like the big ones that do each state change. So if you want to do draw an image, you do a DO first, and you do whichever operators like go and grab the X object with the image file in it, and then you escape back out of that state. And when you put some text in, you do PT, and then all the text operators, and you do NT, and so forth. So there's actually kind of an interesting pair that basically say ignore everything between these tags. So if you want to just embed arbitrary stuff in the middle of your graphics screen, you can just stick it between these two. So JavaScript. So all the metadata in the document, like the author, the title, and things like that are both mutable and writable from JavaScript. A lot of malware is actually starting to use that for obfuscation purposes, and I'll get to that in a moment. So pretty much these are like a couple of the JavaScript methods for grabbing various bits of data out of the document. Get the icons, or get all the links on a page, or get the nth word on a page, and so forth, or the number of words on a particular page. And some of these can actually get quite complicated. For example, you can get the boundary box coordinates for a box around a particular word on a particular page. And if you're trying to evaluate a PDF file, you need to essentially render a page graphically to find out what the answer to this, will actually be. Because based on your font and what the size is and the position on the page and stuff, you get completely different coordinates out of this, obviously. So you can also annoy people who do a lot of analysis on malware, because usually by the time they get the document the file to analyze it, the file name's been changed. And if you make that as part of your encryption scheme, it's just a bit more work, I guess. But it's a piece of information that's sort of external to the document that sometimes gets lost. But yeah, you can from a PDF, you can also open another PDF file and then call objects within that PDF file. So you can spread your document out across multiple files, or your exploit, say. And there's a bunch of really I don't know, interesting methods that have been restricted now. For example, you can add and delete menu items from Acrobat itself. So you can add new things from the file menu, and then you can like click on them or send click events to the menus, things like that. Anyway, these are all restricted in the current version of Acrobat, but the older versions you can still do all this stuff just from any document you open. So yeah, Acrobat 6. Anyway, you can turn them back on if you go into your preferences and check that. So anyway, similarly, there's several methods that write files to the disk. A bunch of these are some of these are also restricted these days, but basically you can save form data, printer stuff. Anyway, you can extract a page onto a new PDF document in some arbitrary location. Export signing certificates and so on. Anyway, so there's some other quirks with the JavaScript engine that's in Acrobat. It's slightly different from the one that's in most web browsers. And I've discovered this recently, or rather Sebastian Horst discovered it recently and pointed it out. But the type of a global variable in Acrobat never changes. So so normally if you have a bit of code like this, where you start off with a variable as a Boolean and then you set it to a string in like Firefox or whatever, you will essentially have that string value. In Adobe, if you start off with a variable as being a Boolean and then set it to a string, it remains a Boolean. And there's a couple of little quirks between the JavaScript implementations like this that if you're trying to do automated analysis of the JavaScript by executing it, you'll run into a lot of these. Or rather, you can use a lot of these for preventing analysis thereof if you're writing exploits. So current malware is starting to use some of these techniques. Just some of the, mostly just the metadata related stuff. There's a couple of toolkits, there's a few other ones that I don't have on here and stuff, but needless to try and back up over. A lot of targeted attacks do this. 1 second. And you can, since basically you can also access the QuickTime libraries and the Flash player and stuff like that. Any vulnerabilities in like Flash or QuickTime or any of these other formats, you can just embed one of those files into the PDF and exploit the library through Acrobat instead of whatever other vector you have. So anyways, basically exploit it. There's a couple things to make. It is to make it a little bit tricky just to grab the code out and run it through SpiderMonkey or whatever. So it checks if there's an app object defined, and if so, if not, it goes through a code path where it just generates a bunch of gibberish. But it'll generally essentially grab an annotation, which is basically like a sticky note you can stick on a page, and pull the subject of the sticky note out and exec it basically. And there's a couple other fields that, in the document that can be used for this also. And they're basically, most of the malware these days is basically just storing bits and pieces of the exploit code in a bunch of objects and just kind of pulling it out, decoding it a bit, and gluing it all together and execing it. So it's not doing anything too terribly fancy. Primeback was interesting because it essentially has pages and pages full of random words, and then basically just picks a certain word off a certain page, and or rather sums a whole bunch of words from a bunch of pages, and essentially it pulls the data out of the document text itself that way. So yeah, so basically a lot of the target text, they do basically the same sort of tricks. Although they have some other weird quirks in them, like they'll do like a ginormous blob of nulls or an executable file sitting in the middle for some reason. I'm not sure if it's something about the tool that is being used to generate them or something like they, I'm speculating they may have generated a PDF file with a big empty space in the middle and essentially just dropped the whatever arbitrary executable they want for that to attack and just left the space in, because all of the because Acrobat doesn't care about like anything like that. So I'll explain next. And embedding stuff. So yeah, like this was the one of the Flash vulnerabilities from last year, and in terms of the initial attacks that were using this, were basically embedding the Flash file instead of PDF and mailing it out to a couple of certain targets. This is the old libtiff vulnerability from like a couple of years ago, and Acrobat was actually still using the same old code for it. So anyway, so basically, an exploit against the TIFF library was possible through Acrobat here, for example. Anyway, so so it's a really common thing that occurs in a lot of protocols and a lot of languages and stuff like that. Like ASM1 has terrible problems with this. There'll be two different ways of essentially defining the length of a string, and if you give a program both, which one does it use preferentially? There's if you remember all the X509 attacks from last year, where you stick a null byte in the middle of your common name, and you end up with an X509 certificate that certain SSL implementations read as being either one whole long string with a null in the middle, or just the beginning part of the string up to the null, depending on whether they go through a C library or not. There's a similar sort of things with the PDF format. So, so basically, given a string object, this is a well-formed one. And you see there's both a length explicitly defined and also a beginning and an ending terminator. It turns out that Acrobat ignores the length, so you can set this to be anything, or you can even set it to be nothing. So so basically Acrobat's only really looking at those two, except if you have nested objects and terminators, you can actually leave that terminator off also, and this works just as well. And when I say Acrobat processes this without error, I'm doing all the testing on 9.1.3. So other earlier versions and other PDF readers will tend to throw errors on that kind of stuff. You can, if you want to restrict your document to certain specific versions of Acrobat, or rather older ones, the newer versions of Acrobat don't accept this particular header anymore, but the older ones do, and so you can stick this at the beginning and open just fine with an older version of Acrobat, but newer ones won't see it as being a PDF file. So there's a lot of quirks like this that basically allow you to essentially create a document that will only work on a specific version of a specific PDF reader. So one of the other things, things that aren't really defined are perfectly okay. They're essentially alias to the null object if they're not defined. So some things that aren't recognized are also completely ignored. Anything in the middle of the file that's not recognized token. It is just silently ignored. At the end of each PDF file is a reference table that essentially is an index to where to find each object in the file, but it's not really as necessary as the specification docs. Generally, a cross-reference table looks like this, and basically, this is object number 0. It doesn't exist. So, but object 1 starts at offset 10. That's 10 bytes from there to there. Object 2 starts at the 98th byte, which is 98 bytes from there to there. Object 3 sends 147 bytes in, which is there. So that's 147 bytes, and so on and so forth. But these numbers can be completely arbitrary and bogus. So this works just as well, and actually you can leave them off entirely, and it works fine too. One of the other requirements according to the documents is there's a PDF header at the beginning, somewhere near the beginning of the file. And it needs to be somewhere in the first 1K or so of data, but really it's only looking for this substring of it. And so if you essentially put the header about 1,020 bytes into the beginning of your file, it's still okay. So all the junk you put at the beginning here can be anything else, like say well-formed GIF or a video peg or a zip header or Windows APXE and so on. So you could there's a really simple trick you can do to create a zip file that's also a well-formed PDF file, and basically, since everything before the PDF is ignored and everything after the PDF is ignored, you can just store the PDF in the middle of the zip file with 0 compression, and Acrobat will read it and open it as a normal PDF file, and all your unzip programs will also read it as a perfectly normal zip file. So one of the things you can do is so it's me demonstrating. So this is generally the general structure of a zip file. It's basically a entry header and then the actual file itself. And then at the end of the file is the single directory structure, which is kind of a copy of all each of these with their offsets, and then a comment, which is optional. So you can you say take the PDF, chop it in half, and put the first half in a file, and then put the bottom half and say comments, and essentially interlace each part of the PDF and the zip file together, and both your unzip program and Acrobat will ignore each other chunk. You actually do it. You can build it like this. So that's the zip header. That's a PDF header. That's a zip header. Or this is for each of the directory objects, and then this is the trailer, which is kind of it says UFF or UF there. So. Anyway, and the offsets will be leave off here, but you can fix them if you want, although Acrobat doesn't care. So the EOF mark, the spec says it's supposed to appear at the end or somewhere near the end or be list after all your other objects, but actually you can do the opposite. So you can even put it at the beginning of the file if you want. It's basically ignored. So this is okay to do, and I don't know if you can, here, was it? It's cut off from the top, up there. Oh well, anyway, you put that there, and you can still use this object here, even though it's after the trailer. Anyway, yeah, this is what I was saying. You can, one of the things you can do is take each part of the PDF and stick it into a piece of metadata in the zip file, like the file name, for example. So the quick way to do it with like shell commands is to basically name the file, what the header going to be, take the header out of the regular file and just store it, and you get a zip file that looks like this. And Acrobat sees the PDF tag here as the main file. It's the file name of the zip there, and this is basically the contents of the zip stream. But essentially, everything from there to there is ignored by Acrobat. Everything from there to there is ignored by Acrobat. So Acrobat only sees these bits, and it's still well formed as far as Acrobat's concerned. Although if you unzip this, essentially you end up losing the header. And so it's when I did the antivirus tests later, essentially every antivirus engine, I guess, sees, oh, this is a zip file, unzips it, and it stops being a PDF. But handed as is to Acrobat, it'll still be a PDF. So you can also leave out the end stream and end object tags, but you can't do it both at the same time. You do need at least both of them. So if you're doing a bunch of objects, you can leave out all the end objects. And if you're doing objects with streams, you can do this, but you can't do both at the same time, because if you do that, then it will start to associate closing tags with earlier opening tags in some bizarre way. Essentially, you end up nesting the objects in some unexpected ways. So, anyway, you can leave most objects out. You can leave just about every object out. You need one page index, but you don't actually need a page for it. There's a catalog type that is necessary, and but most object types are just sort of assumed, so you can leave those out. And print all the sizes and lengths of all your data can be left out. So you can take, so if you take everything out of a PDF file, this is what you're left with, which is a well-formed PDF that will launch October JavaScript. Well, yeah, basically any JavaScript when it's opened. And that is pretty much all that's necessary. This is what's actually required by Acrobat in reality. So there's only one line feed that is necessary right there, and actually, I discovered later, you can actually replace this with a null byte and save one byte. You can also make this a little bit smaller if you do a closing action, because it's a 2-character string instead of an action. But anyway, as I said, so you can, it's pretty easy to embed this in a very small place. This is it's stuck into a zip file. Here's a GIF file with PDF as a comment, so you can essentially pass this GIF file to Acrobat and it will open it as a PDF amongst the JavaScript. But most stuff will say, oh, this is a well-formed GIF file, because it is also a well-formed GIF file. Anyway, this is an HTML file that's also a well-formed PDF file, and so on and so forth. That's URI encoded and stuff. It's use your imagination for the sorts of things you can do with this. So the other thing is you can do is if you add the same object multiple times in a document. Generally, all but the last one's ignored. So if you define object 7 twice, there's 2 different things. Essentially, this one always wins, even if your reference table points to that one. And if you have another cross-reference table that also points to that one. So, because you can have essentially multiple copies of everything in the file, and it's sort of the way that editing is done on PDF files is basically just append new versions of older objects to the end of the document, and those take precedence over anything that was defined earlier. So you can also, for a bunch of the object types, you can also reference the same object from multiple locations. So this is 2 different pages that have the exact same contents, for example. One of the other things is you can the list of objects is supposed to be in a directed, a directed acyclic graph. But if you actually do make a cyclic graph out of it, there's sort of a question as to what various parsers do. Acrobat rejects this, rightly so, but I don't know if there's any other PDF parsers that will say go into an infinite loop and handle something like this. It's one of the other things for future research. So, so the results of this. How many people want to guess at what the results of this test are going to be? Yes. So, yep. Actually, they're not even parsing PDFs. That's the thing. So, so I took a 2-year-old exploit and made a very well-formed user-to-read, 7-bit ASCII version of it, and set it up to VirusTotal. And I know VirusTotal is only running the scanners and like doing a static analysis and blah blah blah. This supposed to have some sort of memory runtime blah 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 thing and stuff that isn't done on there, but yeah, whatever. Anyway, so VirusTotal. So I put the stuff against VirusTotal, and most of them didn't detect the 2-year-old exploit doing absolutely no fancy encoding or obfuscation or anything at all in the slightest. So this is what I stuck into it. It's basically straight out of Metasploit, a little bit deobfuscated. Right? And basically 9 out of 41 AV engines detected it. Most of them were generic signatures, as you can see. And most of them were actually, what they were looking for was the unescape and the %sign U characters for the shellcode. So if you take them out, and normally when you do obfuscation, you can basically just essentially fetch these out of the metadata in the document. So you can make this, this would be the title of the document, this would be the author, whatever. So if you do that, then it drops down to 2. And this one right here is, well, I have it on a later slide, but in terms of this particular screenshot, will also flag Gmail as being malicious. So it's the horribly overly sensitive heuristic signature for this. I forgot which company this was. So yeah, if you actually cut it down to just the exploit itself, nobody detects it. So I'm not surprised. Is anyone surprised? No. So yeah, most in the wild exploits have just about 0 detection on VirusTotal. And I'm not going to make this into a commercial thing, but my company detects all of these attacks. And if you want to hear about it, ask me about it afterwards, because I'm not going to talk about it right now. But so this was something I was using. So I did the zip file trick, where I just stored it. And everybody can still see it, because you can just zip the zip file and you get the same original file back out. This one just ended up being slightly different for some reason. But if I do the trick of stuffing the header to the file name, then it drops down to 5. Except for, yeah. And they're basically just ignoring the syntax a certain amount, and then I do this. And if I just do essentially, the flake to code is basically the deflate algorithm that's in zip and gzip and paint and so forth. If I just, it's one of the many filters you can do on streams in PDF, and if you just take the JavaScript code and deflate it, then it drops down to 2. And keep in mind that this is the signature that detects like everything as being also potentially eventual exploit. But so to do, I should really try this with some other exploits and some other tests. But no, I don't know. Nobody should really be surprised that AV scanners are completely trivial to evade. So, on my to-do list is, I believe it's possible to do heap spraying using the graphics operators in PDF. I was hoping to actually have something done by my talk here, but I've been too busy to work on it, really. But essentially, you can just paint a copy of your sled and your shellcode and stuff into memory using like an image or one of the other, one of the many graphics operators. There's a bewildering, amazing array of operators available for you. So, like for example, there's a single operator that will do the cross product between two triangle meshes, or the cross tensor product. It's no difference. All the math operators are basically essentially all the graphics operators is math operating on matrices, and so one of the things you can do for hiding your shellcode or expletive like that is take your exploit or your shellcode or whatever as an image, XOR it, or do some sort of alpha channel subtraction on it, and essentially you get with against white noise, say store the white noise and whatever the answer to that is in the PDF file, and then merge it together with the appropriate graphics operator to recalculate the original back into memory, and pretty much anything that's scanning for this basically needs to do the same graphics operation in order to get the data out of it, otherwise it's white noise. So, anyway, I found a couple the other day, somebody had apparently already done a proof of concept of heap spraying using inline images. So there's an example there. So I meant to look at it. They also did did it using ActionScript, which is actually been used in a couple of live exploits already. So it's also possible to create a PDF that looks completely different on every OS platform, language locale, and version of the reader that is open. And it's really possible to do all this without using JavaScript. Hypothetically, it should be possible to write a database scanner in PDF, so in your PDF file, it will go and try and find all of your local databases and connect them and stuff. Although printers these days have a PDF engine in them, and it may be possible to do interesting things from the printer on the network. This is another thing that needs a bit more research. TrueType fonts have a ton of graphics operators, and it's almost, if you actually read through the spec, it's almost like PostScript as well. It's there's actually in the last month or two, there's been a whole bunch of ODAs basically discovered in the TrueType rendering engine, a bunch of PDF engines. So I suspect there's a lot more lurking in the TrueType engine, and one of the things there's a type 4 function for doing dot screens and stuff like that, and this is basically a subset of PostScript. You can also write short chunks of PostScript code in the PDF file that also don't rely on anything else like JavaScript if you turn that off. So I've been trying to come up with something to say more than we're totally screwed. They're apparently Acrobat. They did recently announce that they're going to start sandboxing Acrobat later this year. They'll have a version that is sandboxed, so that you pull all these instances of Acrobat, you can't play it back out to the regular system. I don't know quite how that's going to work in reality. But as it is right now, PDF is the the largest vector for attacks. There's a no-day exploit used about every 90 days in the wild. You can kind of do anything from Acrobat and make it completely undetectable. So, I don't know, it's bad. Anyway, so, any questions?
As I said, we have this tradition that people in Sweden usually don't ask questions.
Okay.
Which is why I get on stage and start asking questions and hope that everybody else follows.
Right.
So I was kind of expecting you to say, just please stop using it. Stop.
That's a good idea.
Quick conclusion. It sounds like it's a completely arbitrary runtime environment, able to do pretty much anything. And nobody remembered to check that. Sort of.
Yep.
It's so much functionality that no one uses it.
Yeah.
And it's like the developers should be putting stuff into it. Have these things always been there and nobody saw them? Or are these still things up in there?
For at least most of these things have been around for at least a decade.
Are they still putting stuff in there? I mean, is new functionality being added?
Yeah, I'm trying to remember, I read through the changes. They are still adding stuff. Mostly, let me think. The last couple of revisions I saw were mostly adding a bunch of extra DRM code stuff and fixing a couple other things in spec. I don't think there's really been a major feature added, I think, since, I don't know, 7 or 8 or something. I don't know, I can just research and get back to you.
Instead of removing functionality,
they just keep
are you sure boxes everywhere?
Yeah, because also everything's backwards compatible all the way back to version 1.
Right, even though nobody actually uses these things.
Yeah, and you can still use all the old stuff too.
Do you feel that you get any more sort of, I mean, there is awareness in here, I know, any public awareness of maybe not using the Acrobat Reader at least?
A bit. I don't know quite how public this is. I know some people, anyone who's really looked into PDF has been saying, don't use Acrobat. Dier keeps recommending Foxit, and I use XPref and Preview and stuff. I forgot to mention, when I was doing I wrote a bunch of test PDFs for this also, and I ended up creating a couple of PDFs that would render the pages backwards in the OS X Preview versus in Acrobat. So if you put the page tree in a backwards order, Acrobat will put it back into one order, and then OS X Preview will put it into the opposite order. Anyway, there's a lot of quirks like that between different PDF implementations.
All right. So the problem is getting worse because people are finding the problem. They're not actually making the problems worse. They're not really making anything better. It doesn't sound like Sandbox and Reader is going to be a good idea either. I mean, if they really want backwards compatibility, blocking each one is not.
Well, I mean, arguably, your document viewer shouldn't necessarily be able to read and write arbitrary files on the disk.
Exactly.
And launch arbitrary programs and make arbitrary network connections, which you currently can do.
Removing the functionality is a better choice than Sandbox and Reader.
Well, the thing is, there's definitely actual major organizations that are actually using those features.
No,
that's why for each one they take out, they stick a little thing in the preference menu to turn it back on. Because there's apparently people actually using those features.
So their stance is not to pull stuff, Acrobat's stance is not to pull stuff out of it.
Right, they just switch it off.
And they just said that they're going to sandbox it and see what they actually do.
Yeah.
So what's the recommendations to corporations?
I don't know, my company detects all this stuff. I don't know, some are starting to switch from Acrobat to something else, and some are even considering just banning all PDFs entirely. It sort of depends on the paranoia of the organization, I guess. I know there was somebody that with ISC did a survey a couple of months ago on like what people are doing with regards to PDFs, and I forgot what the results were, but
wow, it's bleak.
Yeah.
All right, questions from the audience? No, we got lots of. No, we only have one mic, so I have to run around.
Yeah.
All right.
Are there any exploits designed for Acrobat Reader that are effective even in like Foxit Reader?
Well, the launch design flaw, I guess you can call it, worked in Foxit. And it actually worked better in Foxit than it did in Acrobat, because Acrobat would prompt the user first if they wanted to run command.exe, but Foxit would just blindly run it silently. But yeah, I know actually I think Foxit was using the same TrueType library as the iPhone PDF renderer also, because the recent jailbreak my iPhone exploit, which was going through was a PDF file that was essentially hitting a vulnerability in the TrueType library there, also worked in Foxit. So, because a lot of the PDF readers kind of use the same libraries for much of their code.
Okay, one that might be somewhat dumb is asking if you found anything where you could do wildcards or circular references.
Oh, in the syntax?
Yeah.
I did try a few circular references. Acrobat rejects them, but I haven't tried it with other parsers.
And then the other thing would be for context indexing and archiving engines.
Right.
Have you played with this?
No, I haven't played with it yet, but yeah, there's a whole entire chapter in the ISO spec for interfacing with that.
Because I'm thinking of archiving products and.
Yeah.
Thanks for a nice presentation. Have you analyzed PDFs which use, besides play decoding or encoding, some crypto encoding and decoding? If you have analyzed, can you describe the techniques they use or how they look?
I haven't seen any that actually do the encrypted object streams yet. Although there was one of the many quirks about it is that if you encrypt an object with a null password, Acrobat can automatically figure this out and just silently open it without prompting the user for a password. So essentially the document will be encrypted, but Acrobat will open it as though there was nothing unusual about it. But I haven't really seen much that's this malware is taking advantage of that level of crypto yet either. There was an exploit toolkit that was doing a bunch of crypto code in JavaScript for a bunch of its web-based attacks, but I haven't seen any of that ported into the PDF documents yet. So,
thank you.
Yeah.
Very well. More questions? Here's one.
Is it possible to write a secure PDF here?
I think so. It may have to drop a couple features.
Yeah. But is the language broken or is it?
Actually, the language itself isn't too bad. I was trying to figure out a way to make it say like Turing complete, which just would be bad, but it seems to avoid that. Mostly there's a lot of ambiguities in it that the spec just doesn't. Pretty much when you read through the spec, pay more attention to what it doesn't say than what it does say. Because you could, I suppose your Unicode parser is very strict about what it restrictive in what it accepts. It's probably a lot better than the current situation we've got, where the parser just tries to make a best guess at what you probably meant when it finds early input, which is what it's doing. But it leads to a lot of really undefined, unexpected sort of behavior.
One way in there.
Thank you for a nice speech. In a situation where you have a website and you want to allow users to upload pictures, I'd say it's a decent policy to decode pictures first and then re-render them as new files in order to make sure that they don't contain the crap. Would you say that such a solution is doable with PDF? I mean, could you parse the PDF and re-render it if you want to contain just graphical elements?
Quite possibly, that might actually work.
I mean, without having the server owned in the process, obviously.
Yeah, there's currently nothing that exists that does this, but I think it's feasible to do so. So, yeah, you'll end up probably rejecting a lot of documents. Well, kind of one of the reasons why Acrobat is so liberal in what it accepts for input is because there's an awful lot of stuff generating broken PDFs as output. So.
Any more questions? No? In that case, thank you so much, Celia.
Okay.